Hi, everyone, and welcome to day 2 of Launchable Foundation Models. Before we get to John, this upcoming speaker panel is brought to you by our friends at Perkins Coie. I've personally worked with Perkins for almost 20 years, both as a founder, forming my companies and going through the journey of all the way to sale, and also 20 plus companies here at Madrona Venture Labs. They're our partner in forming and spinning up companies. If you're considering a new law firm, we highly recommend Perkins. They've been awesome partners. Great. Okay, so let's get to the panel. I have the pleasure of introducing our moderator for today, John Turow. John has over a decade of experience in cloud computing, most recently at Amazon AWS, where he launched several new services and led product teams for TextTrack and Recognition, among others. Prior to that, he co-founded and led a cloud computing startup, so he has a ton of experience. He joined Madrona about a year ago as a partner to focus on applied ML/AI, data infrastructure, and open source business models. And in a relatively short amount of time, has established himself as a leading thinker on foundation models landscape and has played a key role in bringing this outstanding panel together. So I'm thrilled to welcome John to Launchable.
Thanks, Mike. Great to see you. Great to see everybody here today. Well, this is going to be a lot of fun. We've got some really exciting speakers, and I'm really pleased to introduce the speakers now. I'll start with Irina Rish, who is a full professor in the CS and Ops Research Department at the University of Montreal, and also a core member of the Quebec AI Institute. She holds the Canadian AI Chair and the Canadian Excellence Research Chair on Autonomous AI. And she focuses on machine learning, neural data analysis, and neuroscience-inspired AI. So welcome, Irina. Next, I'll introduce Ludwig Schmidt, who is an assistant professor in the CS at the University of Washington. His research interests revolve around the foundations of machine learning, often with a focus on data sets, evaluation, reliable methods, and large models. He's a leader of the Laion project, which is really important as an open, large-scale data set for training next-gen multimodal models. And that project and the paper around it received an outstanding paper award at the most recent NeurIPS conference. Last but not least, I'm really pleased to introduce Saurabh Baji, who is a senior VP of engineering at Cohere. Saurabh is an experienced tech and people leader who knows how to build stuff and deliver it at scale across domains and large and small companies. And he previously spent time at Unity, Quantcast, and AWS, which is really close to my heart. So thanks everybody for joining today, and welcome to the panel.
Cool, thanks for the invitation. Excited to be here.
Yeah, thank you.
Same here, thank you for having me.
So I want to start with a question that I think is going to be near and dear to the hearts of the founders in this room today, which is, how do you connect an idea to reality? And so I want to start with a question for a founder who has an idea. How should she evaluate whether it's realistic to build that on top of foundation models today, or will be realistic soon, or whether it's a total fantasy or science project? I'll start.
I can get started.
Yeah, go for it, Ludwig.
Okay, cool. Obviously, this is a difficult question. It depends a little bit on sort of like what technical expertise you bring in your team to the challenge of taking research ideas to a product, right? Like if you have sort of like a world-class research team and you can sort of like take any idea from a paper and turn it into working code, then it opens more possibilities than if you maybe don't quite have that ML talent and you're sort of like more bound to what's currently available in existing mature code bases. But what roughly means sort of like, in terms of these 3 levels that you mentioned, sort of like science project, near term, and realistic today, I would say if it's not even in research papers yet, I think it's a science project. And I think it would be quite ambitious to do that. I mean, some companies do that, again, it depends on what team you build. Like for instance, like one example that comes to mind would be Adept, for instance. Like they have like a superstar team with the transformer inventors and so on. And then they set out to build something very ambitious, which definitely goes beyond things that are currently in research papers, but they build the team or to have the team to build it. But if you don't maybe quite have the transformer inventor on your team, then I think it's good to sort of as the reality check, is this in a paper or not? And it's like, if it's in a paper, I think that's good. Then the next question is, does this exist in research, sort of like in mature research code bases, right? So like, there's again, sort of like a range from someone dumps their research code onto GitHub, and this is great and already valuable, to this is like a repository with like 5,000 GitHub stars and many contributors and something you can more easily use and build on and scale. And I think sort of like, if you already have code at that level, then I think this is probably realistic today to use. If it's reliable enough for your application, it's a separate question. But I think that would be sort of like, I think maybe the second dividing line. Is there a good, stable code repository out there for the thing you have in mind?
Yeah, I completely agree with that. And it's definitely code base, or like existing code base might be very important. And there are interesting, it could be even interesting paper with particular kind of methodology, but even making that, say, scalable on multiple GPUs may be non-trivial. So even the fact that there may be existing paper, existing method, and even existing code, say by Lucid Rains, doesn't yet mean that you can just take it and, for example, use in your application so easily, and especially try to scale it to, say, multiple GPUs. But besides kind of the code bottleneck or kind of the guarantee that the method will work, there are actually many other aspects. First of all, I mean, depending on your application, on your idea, you also need to know what the limitations of the foundation models could be. Say you're trying to build on top of a language model, but if your application will require, for example, very long context, that may be not something that the foundation model can provide you yet. And well, it can be overcome and so on, but then you really need to do some research on how to add extra memory. Or the question, depending again on your application, could be, do you need to collect a lot of domain-specific data, and how difficult it is to do so? And say your application could be medical and you're trying to do some kind of like dear to my heart therapy applications. There are all kinds of issues around those data and how available they could be and so on and so forth. So maybe this data bottleneck can really delay whatever you're doing, even though you have language models available and so on and so forth. And of course, like ethical considerations about like, yeah, we all know that it's a very sensitive issue these days. Yeah, you should be definitely sure that you kind of will not get in trouble with whatever applications you're building. And as I'm joking sometimes, maybe you hire really good lawyers first and then good developers.
I think those are both really truthful perspectives. I think I might have a bit of a different take. While I agree with both Ludwig and Irina, I think as a builder at heart, I think the best way is to simply try it out. So if you have an idea to build something on top of foundational models, the best thing going for you right now is that access to foundational models has never been easier. You have so many intuitive interfaces, right? You have powerful all-in APIs. Like, I'm obviously biased, but Cohere has a generate endpoint, a classify endpoint, and more. You have chat-based interfaces, as we all know now, and you could find them hosted on a website or available to your favorite app, like WhatsApp or some other thing. Your playgrounds that let you explore various use cases. And if you have some sensitive data, Irina brought up the point of data and domain-specific data. You have other options. You can do deployments into private clouds. You can just download things to your local machine and try them out. So I think at the seed stage, something that you just want to try out, there's pretty much nothing stopping you. I think the biggest thing that I have found when working with founders is that you just don't need to be an ML expert anymore to be able to start. If you have decent development skills, you should be able to use any and all of these means to just be able to start exploring what foundational models can actually do. And we have Jay talking right after this. He's going to go a bit into what generative models can actually do and cannot do today. And one of his quotes that I really like is, generative models are impressive, but they have a hard time being predictably impressive today. And so, you have really powerful foundational models in your hands. It's really easy to evaluate realistically what they can do today, maybe a little bit of prediction on what they could potentially do tomorrow. I think the last part of your question was, what is really a science project? Ludwig spoke a bit on this as well. But one of the latest things to come out is prompt engineering, right? This is effectively wrangling the foundational model to get exactly what you want. And as we've all seen, it's an art, not a science. So this can potentially get you today what is maybe more predictable in the near term. I think beyond that, anything that has not already appeared in research would be not realistic, and so not worth going after. But even over there, the community is so amazing. I think Cohere, for example, has a Discord. Most companies do. We've had 2x the engagement already, 2x the members just in the last quarter. And so you will find a number of people with like-minded ideas and with different backgrounds that can potentially help evaluate what's possible and what's not.
You know, I think so thank you, each of you. As I try to synthesize that, there's a term of art, not science, which comes out ironic because we're also speaking about science papers. But what strikes me is that the really clever founders in this area are the ones who have enough imagination to discover something that actually can work a little bit before other people can, and the conditions under which it can work. So, you know, for example, you know, take something relatively, well understood in our space, like Jasper AI, which is generating marketing copy. There's a couple key insights to that. One is that you don't need a lot of extended context for it, to your point, Irina. Another is that, you don't need to know whether or not it's going to be right or not, because a human marketer is going to read all these pieces of content, and if something is really absurd, we'll just throw it out. And there's that kind of co-pilot metaphor. And so there's this alchemy that comes of clinically understanding what is possible, and then imagining, dreaming, daring about what is, what you could still do, notwithstanding those limitations. I like the point that you said, Saurabh, as well, that access is greater than ever too. It feels like, am I wrong? Am I right that access is greater than it was 3 months ago to all these models?
Every single day.
Yeah, no, I think it's also exciting. So just how quickly this is happening. Like, for instance, when DALL-E 2 came out, like last year, I thought, man, this is amazing. And then Imagine came out at Google, also really great. And it's going to take 2 years until we have the open source, and sort of like a little bit of a bummer. But then sort of like a couple of months later, Stable Diffusion appeared and so on. So yeah, no, very exciting stuff.
I think the level of skill you need in potentially more esoteric areas is also just going down so much in order to be able to get access. So not just the form of access, but the abstraction that you actually have available matters so much as well. And so this is where I think being able to actually play with the model is one thing, but then also anything and everything, wrapping it such that you can just use it directly without needing to care about anything else. I've seen that make a huge difference.
I think we've seen this, I'll sort of gesture to Mike off stage, because I know that even as we started envisioning this hackathon event, this hack week, we were saying, well, gosh, how are we going to make sure that these founders have enough of a stack and enough throughput and concurrency to build even a hack project? And we're happily in a world where that's not, I don't see a lot of people stressing about that this week.
Well, also take into account that it's not only, as we all know, it's not only the models and APIs to them released by companies. I mean, the whole kind of tsunami of open source AI, it shows no signs of slowing down, vice versa, right?
Yeah.
So people are getting more compute, and people are training completely open models, whether it's language or a multimodal and so on and so forth. It's just a matter of time before pretty much the analogs of anything, from multimodal to ChatGPT to Gato, all of it relatively soon will be open sourced. Yeah,
Cool.
so it's very interesting also how it's gonna, what's the dynamics gonna be between the open source communities developing those models for free, kind of for everyone to use, and the companies, because I think the dynamics already kind of started in an interesting direction, that open source was applying some peer pressure to companies to release the models and interfaces faster. And I think it's only going to be going in that direction. So it's going to be interesting.
Yeah, I think so. There's so many things I could say about that. There's one thing that kind of strikes me. There's a paper out there called, you folks will know the expansion and I don't, it's called Helm from Stanford, about evaluating all these different models.
Yeah.
And what Helm shows is pretty striking. They say, look, the proprietary models just win on accuracy today, and they did last year too. The gap is closing, and yet the sophistication and the imagination and the resources that went into these proprietary models is also kind of pushing the boundaries on that. So we see, I wish I had a less warlike metaphor than an arms race. We see a race that plays to the benefit of all the founders who are here.
And I think open source is catching up.
Cool.
I think it's a good question. I mean, obviously, I'm a big fan of open source AI. I'm involved in it and so on. Since you mentioned language models, I think it's also good to keep in mind, sort of like from looking at the very thorough evaluations in the paper that you mentioned, that GPT-3 came out in 2020, first half of the year. And so like it's almost 3 years later soon. And we still don't have an open source model that is as good. So we have models at the same scale with Bloom and OPT 175 billion, but their performance isn't at the same level. This is one of the things the paper showed. So I think there will be more, one second, I think there will be more models coming out that hopefully catch up. But I think it's not clear to me who's winning at the moment.
I think Bloom at least was performing on par with GPT-3 that came out in 2020. Of course, it was probably not performing on par with Instruct GPT, but in a sense, I mean, again, it was maybe not completely fair comparison, but I wouldn't say, I mean, there is Bloom indeed, and of course, there are various plans to train in the next several months, various state-of-art language models. Probably I shouldn't talk about that until we train them. I will tell you later once they're running. But there are multiple parallel efforts like right now. And I think the difference between what it was 3 years ago in open source and now is that open source is gaining access to more and more compute. And that's why the gap will be actually closing. Well, of course, there is advantage to large companies in terms of structure and organization, because open source, it's essentially those chaotic communities on Discords, and literally like managing that is like herding cats. And yet, I mean, there are pluses and minuses in more like chaotic environments. But yeah, so it's a very interesting dynamics, I would say. So it will be interesting to see how the game continues.
I agree.
Again, I'm a bit subjective here because I'm also part of Laion and all these open source projects.
Yeah,
are we going to beat OpenAI, and when?
I lived this in the past with things, on data with Hadoop and Spark, which seems like so far back now. But I think there is something to be said for open source catching up, which is fantastic. But I think there are possibilities for other interesting paradigms to emerge as well in terms of partnership with open source. I think the core point I see is, while you do have proprietary models having an advantage today, you can't just count on that to stay, and definitely not for long. So one part is just, do you actually focus on the model itself, or do you actually focus on building other things around it? And so a product focus versus a model focus can often make things very different. There's also, John, as you know well, the undifferentiated heavy lifting part, which is sort of the AWS tagline, right?
You stole my next question, dude.
And so what can you actually build to make things easier and easier for the builder community? I think foundational models are exactly that. You can 1,000 flowers should bloom on top of that. And so in order to make that really happen, how do you keep making things much easier to actually use? That's what I spend a lot of time thinking on.
Okay. I have a question from the audience before we move on. Let's see. So there's a question. Maybe can you all see it in the chat? I'll read for those who can't.
Yeah, it's a good question.
I heard conflicting information about whether the model will get better with more parameters. And what's your take on that?
I can start answering, and definitely, yeah, you're absolutely right. And I think that's kind of been a discovery, like empirical discovery, when within the first year of the large model kind of boom, the 2021, everybody started this arms race building larger and larger models, essentially following scaling laws from Jared Kaplan's original paper, which kind of was suggesting that if you have like more compute, you should be also increasing model size like 5 times and data size like 2 times. And then Chinchilla paper, like from last year, that was also NeurIPS, kind of one of the notable paper awards, said that actually if you invest more compute in the data and say grow model size and data like 50-50, you can get better performance and more efficient scaling laws. So yes, I think the increasing size of the models will help, but only if you correspondingly increase the amount of data you train on, and not just amount, but the quality of those data in terms of like information content. So not just large amounts of data, but diverse, because the size of the data is just a proxy for amount of information, just like size of the model is proxy for the capacity to hold this information. So yeah, I mean, it's not enough just to train larger models. You need to make sure that they are trained sufficiently and not like under-trained severely like the first generation.
I agree. And I think there's already enough in the literature about how smaller models are actually beating out larger models based on
Chinchilla. Yeah,
exactly. So Chinchilla is kind of canonical on that. I think with you mentioned Helm as well, and so there's enough evidence in that as well on benchmarks. So yeah, definitely not the case anymore, at least, that with more model parameters, you're just going to keep getting better.
yeah.
So maybe some part of the confusion could be coming from the fact that as you make models larger, they will get better, but for a fixed amount of compute, if you put in a certain amount of dollars for training, the best thing may not be to make the model larger.
Right. Well, and there is another interesting, well, more researchy direction, but I think it will be extremely practical. People are working on pruning models, on sparsity, whether just with regular hardware or with specialized like Cerebrus and so on. But this whole idea of pruning large-scale models or maybe distilling them so they remain as powerful, but much more compact, that ideally you end up having them on your phone or on your laptop. I think this is quite exciting direction on its own.
I think, what you're getting to a bit, Irina, is that we were in a world pre-Chinchilla where, holy cow, training these things cost $10 million, and counting. And so only a few big companies would ever really be able to do that. And Chinchilla showed us, no, you don't need to do that. You can train awesome models more efficiently than that. But wait a second, we've got to run inference too, probably, right? And that ends up being pretty expensive.
Right. So that's where compression in whatever way would also probably be helpful. And keep in mind, Chinchilla, I mean, by now, it's not a recent paper anymore. There is much more since Chinchilla, right? And then there is work from Stanford, from Surya Ganguly's group, another notable paper award, basically beyond scaling laws. Essentially, well, it's still a question like how practical it will be if you really try to implement it, because the idea is that you can use different ranking functions to evaluate quality of your data samples. And if you only choose those that are most important for training, then of course your scaling with respect to data can drop from power law to exponential decay. So you're much more efficient. But the question is how computationally expensive would those ranking algorithms be? and so on and so forth. There was also a very interesting paper a few years ago. Well, I mean, the idea is quite straightforward about essentially focusing on the biggest losers. I think it's from the Google Brain. Essentially, you propagate sample and compute the loss, and if the loss is okay, it's not too big, you just conclude that your model already kind of understands how to model such kind of samples. You just skip it, and you only backpropagate samples that model makes mistakes or like has large loss. So that's why focus on the biggest losers. And that saves, of course, compute as well. So there are various ways to keep pushing the idea of chinchilla that you can have better scaling laws while doing not just scaling, but some kind of a smart scaling. And I think that's where the focus shifted in the past year.
Got it. You know, I want to touch on what you just said, Irina, and go back a few minutes to something you said, Saurabh, about let's just try it. You know, as I imagine what our founders are going to want to do, I think about how do I try it, right? If I'm convinced that some model that I have access to can basically work for a given use case that I'm targeting, how should I evaluate whether the model is going to work well enough with quality and reliability for the use case that I care about?
So that's a great point. I think again, as a builder, the best thing I've found is to work on customer specific evaluation. You obviously have benchmarks that are available. So if you need to evaluate from a scientific perspective, which is definitely something you should do, those are available pretty commonly. But I think for a given product and whether or not what you're building will actually work for your customers, you really need to test in a user-centric and context-specific manner. And so I would say, you know, if you're building with a thesis and you've done the right homework in terms of figuring out what is the real customer pain point you're trying to solve and working backwards from there, and hopefully you have the right users on tap that you can evaluate with, or at the very least get enough data such that you can use that as a proxy to test. But I would say build a prototype, get something in your users' hands, and then just test on top of that. I think there was a follow-up question to the earlier one in the chat, which said most of the best models by big companies might have used all of the web data. Where would be more data coming from? This is beautiful. This is absolutely the crux of what I see in products, because proprietary data or context-specific data that you can get from users is extremely important. And you don't really need to build a foundational model again. That's not the aim. You can use a foundational model and you can actually fine-tune on top of it. So the feedback that you get from your users in terms of real-world data, that is absolute gold. That's what I would focus on in order to actually improve how the foundational model works for you. And that can be a really, really authentic virtuous cycle. And so that can really become the flywheel of how your product keeps on improving.
Yeah, I do agree with that, absolutely. And that relates also to the mode of testing those kind of models or whatever you're going to build on top of them. Yeah, it might be really hard to kind of test their robustness or kind of applicability kind of at once ahead of time. But having the interactive mode of kind of operating with those models and having like indeed customers who not customers, but having testers who are going to be essentially interacting with your model or the product on top of that, and kind of finding, like stress testing it and finding situations where it can be improved, and actually collecting new data that particularly target those weaknesses. Because again, it's really hard ahead of time to figure out what the weaknesses could be. And the example I give, it's not even related directly to foundation models, but think you like driving electric car or whatever, like some modern car, and you would like to change directions that you kind of put in the map there. While you're driving, it may not let you do so because it's programmed for safety not to do so. But generally, it's good rule. Under some circumstances, you want to override it. So you want to have an option of interacting with the system and giving it like specific cases and explaining kind of how to change behavior. So same may apply to whatever system you're building. This interactive, the ability of system to accept and fine-tune itself interactively, maybe not in real time, but I think that's extremely important. It doesn't even have to be reinforcement learning from human feedback. It could be simply fine-tuning with human feedback or anything like that. But what I'm trying to say, it might be much easier to collect case-specific data through interactions than try to ahead of time come up with, I don't know, additional data set to fine-tune the system on. So whatever the environment is for your application, that will determine the interaction type and the interface. But I think that's very powerful kind of concept, better than the offline kind of pre-training approach.
Yeah, I think the question I'm wondering about is, how can I evaluate these things at a hack stage? You know,
Right.
I guess you're going to tell me, you know, evaluate it qualitatively first, or try 100 data points, or how would I do
Oh,
that?
you mean, is there a question about which metrics you should use? Which
Well,
is like, yeah,
I'm-
or like given the metrics, for example, like, you know, your application it's important that you get like truthful information and also like non-offensive and so on. So you have your metrics plus the usual things, just like loss and so on. So you have them, but the question is like, how do you evaluate them kind of step by step instead of kind of spending too much time and compute for that evaluation? Is kind of that the question?
Well, so it just at a really early hack stage, if I'm trying to evaluate, remember the scenario I painted at the beginning, I've got a great idea, I want to see if it's real or not.
Right.
And the first thing we do is we try it out. Hey, it kind of works. So now I want to go a little further. I want to quantify, I want to measure, at least, I don't know, quantify. I want to measure whether the reliability or the quality is there. And I think it's, maybe you're describing kind of a progressive or an iterative process, because I need to have a little bit of data to be able to measure that.
Yeah, I mean, you probably have to start with some simple test cases. Say, I don't know, you're trying to build some personal assistant who will help you make decisions in everyday life, and you would like this assistant to talk to you in natural language, so you build it on top of some language model, right? So how exactly you're going to be testing it? You need some simple scenarios of such, say, decision making, right? And then you may start a bit like stress testing the model with scenarios which are more diverse. So not exactly adversarially kind of, not exactly testing for adversarial robustness, but something like, what if some unexpected situation happens and so on. So basically try to test for, I don't know, distribution shifts in the situations or in the customer kind of goals or objectives. So something like diverse enough kind of suite of tests probably to start with, but and then progressively you can kind of grow it. But I also think that probably what you can do with whatever kind of smaller and simpler initial set, you do the same thing as people do with scaling laws, right? So you look at how the set of tasks, you can call them downstream because you are using that foundation model for your purposes, and your purposes or task can be related like as downstream. So you grow that complexity of downstream tasks or the number of them, and you can also look at the scaling laws, and you can see whether, I don't know, whether system may become less well-performing at some point or something. So you can again do some gradual steps, increasing the complexity of the tasks you ask your system to do, and you can look at the scaling laws with respect to that. That's kind of one option.
Got it. That helps me. Thank you. So, you know, we've got just a few minutes, folks, and I want to leave some time maybe for the group's question as well. But I want to do a bit of a lightning round. So I'll give two questions, and I'd like each of you to sort of pick one and let me know your thoughts. In spirit of bringing together builders and scientists, what is one thing that builders should know about the science of foundation models that perhaps the community hasn't internalized? Or what is one question or signal that science and the service provider teams would like that builders can help us evaluate where we need to go? So what should the builders know, or what would you like to know from the builders? Would you like to start, Irina?
Yeah, well, I mean, for builders, I think it is important to know not just the capabilities, but limitations of those foundation models that they will be using. And indeed, I mean, yeah, they're much more familiar. We're all usually much more familiar with success stories, but I think it's very important to study potential limitations and potential kind of failure modes. Yeah, so that's probably something that builders can indeed learn, well, from papers and also from interacting with researchers. They can just ask direct questions like, where is going to break and like, what's missing? Yeah. Although in a sense, similar question, researchers can ask the builders, say, well, tell me about your applications where you tried the model and it failed spectacularly. Like, what happened? Because we might not be able to kind of foresee all the situations using our benchmarks. Yeah. So in a way, I would say that in both bidirectional question about failure modes and limitations, I think is very important.
You want them to know it, and you want to know it.
Yeah, because builders may know situations just because of discovering them empirically that researchers just don't know because they're limited to benchmarks anyway. And on the other hand, builders who just coming into that area and see that the models are amazing should know that they're amazing indeed, but yeah, nothing is perfect. And what exactly is not perfect, they better know now before they build something.
I was told they were perfect. This is a big surprise.
I agree 100%. I think builders should go in with eyes wide open. And so, you need to be realistic about what LLMs, for example, can do, what they actually are. And so how much or what you expect from them. They can be pretty delightful, but you don't want to fall down hard on something simply because you assume things. The other way around, I have a slightly different perspective. I agree completely on the part about what researchers would want to know or what the science is looking for. As a service provider, right, I think of things in terms of generalization versus specialization as well. And so while everything that's come out initially has been the foundational models themselves, I really want to know from my customers what they're looking for, how much is really yet another ounce of improvement on the model worth to them for what they're actually building versus how much is everything else around it in terms of ease of use actually critical. Because this can make a giant difference in terms of how quickly you can actually get to market for something. And so the model being just good enough as a foundational model is often all you need. And then everything on top of it is just specialization for your product. But if you have all of the right facilities to actually build with, then that specialization can be done by the product itself. And so is that really the most important thing versus us doing things like we, for example, Cohere has a generate endpoint, a classify endpoint. You could do those directly on top of the foundational model itself, but is it actually useful to have a use case specific, more and more specialized set of endpoints? Because then you can rely on those endpoints to do exactly what you need rather than have to fish around and fiddle around and find out how to actually exactly use a general model for it. I think as we work with our customers, we see that question come up more and more often. So definitely curious to know more.
Yeah. One thing just came, well, maybe I should let Ludwig speak, but just one quick example. It was very, very much really bothering me because there is lots of, I mean, not too many papers, but increasing number of papers and all the talk about, for example, continual learning being quote unquote solved by scaling. And of course, it's much more nuanced than that. But indeed, like our papers, other papers, and lots of practice show that if you build on top of pre-trained models, doing continual learning is definitely much more effective and easier. But the question is that, say, continual learning or distribution shift, how much of that to expect? Say, if I have some, like, say, customer comes and say, well, I only want to look how your model will be helping me solve something like rotated MNIST. Well, I'm being kind of ridiculous, but just to kind of demonstrate the point, it's very easy because the distribution shifts are not that large, and probably much smaller foundation model will be just enough to take care of that continual learning downstream. And another customer comes and say, well, and I want this thingy to work when I'm gonna send my whatever rocket to different planets. So the environment gonna be quite different there, and who knows what's gonna happen. Probably I will need to provide a more capable, larger, and trained on much more data model. And I would like to know that kind of rate distortion trade-off. It depends on what the customers tell me in terms of what they expect to see, what is the diversity of the environments and tasks that they want the model to perform. So that's, I think, would be very interesting for the researchers to know and kind of iterate with different developers and different applications, just to understand, like, yeah, what to expect, what you're going to be using that model for.
Maybe
what would you say?
one, just maybe one thing from the research side that could be interesting to know for people more on the product side is that this is all at the moment, I guess this is somewhat clear, but all still very much unexplored scientifically. This entire sort of like foundation model paradigm really only started about 2 years ago, 2.5 years ago. And I think many people, including myself, didn't see that coming in that form. And it's been very exciting, but it's really hard to project forward with confidence what's going to happen in a year, 1.5 years, with some of the exciting efforts underway in different modalities like 3D, structured documents, all of that, larger language models. So I think when you asked earlier, sort of like how to know that in what areas is this reliable, the art versus the science, I think even the scientists sometimes are surprised by things that suddenly start to work at the moment.
I love that. What a great way to conclude that session. So, we're out of time. I think we could easily talk for 2 or 3 times as long, but this has just been so much fun. Ludwig, Saurabh, Irina, thank you very much for spending time with this group today. I think everybody really enjoyed it, hopefully as much as I did.